Hi, good morning, all of you. On behalf of Ramesh Institute of Technology, I once again welcome you all. Today's course, we're going to discuss about multivibrators from analog electronics. Multivibrator. What is meant by multivibrator? A multi-vibrate. That means two vibration levels. One is at low, another one is high level. Low level, high level. The variations from low to high is known as state changes. So basic circuit of the multivibrator is a sequential logical circuit. It can be used to build a multivibrators, counters, shift registers, latches, and memories. But these type of circuits operate in a sequential manner. That means they are required some additional clock pulses or timing signals to cause them to change their states, low to high, high to low. The pulses are generally square or rectangular shaped pulses. That waveform is produced by a single pulse generator circuit. Multivibrators, oscillators oscillate between high state and low state and producing a continuous waveform at the output state. At the output state. The unstable multivibrators generally having an even duty cycle, 50 percentage of even duty cycle and 50 percentage of odd duty cycle. That means even means high state. This is an clock pulse. In that particular clock pulse, the entire clock pulse period, 50 percentage for an high duration and 50 percentage for low duration. This 50 percentage high duration, low duration, the high is occur state changes from low to high in the rising period, and high to low occur in the falling period, falling edge. This is shown in that particular one. So that this particular type of stable circuits are the timing pulses are known as 1:1. In that particular part, we need to identify some important definitions. Active high state. What is active high state? If the state changes from low to high at the clock period of rising edges is known as active high period. Active low state. What is active low state means? If the state changes from highs to low at the clock pulse falling edge period. What is duty cycle? Duty cycle is nothing but an ratio of clock width to the clock period. So this is the clock width, this is the clock width, and clock period, this is an clock period. Okay, the ratio of clock width with respect to clock period. And then what is clock width? Clock width is nothing but a time duration which the value of the clock signal is equal to logical 1 or I. Clock period. What is clock period? This is a time duration between successive transition in the same direction or between the two rise or two falling edges. And clock frequency. The clock frequency is the reciprocal of clock period. Frequency equal to 1 by clock period. Multivibrators types. There are three types. One is astable, monostable, bistable. The another name for astable is free running multivibrator or free running oscillator. That means no stable state. So that it is also known as quasi stable state multivibrator. But they are switches from one state to another state continuously, so that it producing a square wave with a fixed frequency. Monostable multivibrator, it is an one-shot multivibrator that has only one stable state and is triggered externally with return back to their first state. Bistable multivibrators, it is nothing but a flip-flop. They require a two external trigger pulse to change their state from low to high and high to low. Multivibrators, their operation types based on the input. In the unstable multivibrator, there is no need for an input signal, but it generates a square wave at the output as an 50 percentage of on time period, 50 percentage of off time period. So that 1:1 clock time period based on this. And then for monostable multivibrator, it requires an one trigger pulse, negative going trigger pulse, applied as an input. While negative going trigger pulse applied as an input on the triggering pulse period, okay, the output changes from low to high. While the duration of the trigger pulse is completed means the state changes from high to low. And then bistable multivibrator, it requires two external trigger pulses T1 and T2. While applying the T1, the state changes from low to high and it's maintained until the trigger pulse T2 is applied. Once the T2 is applied, then the duration of that particular period, it is transfer the state, change the state from high to low. This thing is shown in this particular output side waveform. This is an cross-coupled astable multivibrator. In this part, the identical transistors Q1 and Q2, that is known as amplifiers, cross-coupled amplifier connections are obtained by R4 and C2, R1 and C1. Here, R1 and R4 are equal value, R2 and R3 are equal value, C1, C2 are selected as an equal value. It has two stable states, that is state 1. When a state 1, VC1 is high, VC2 is low. That means we are aware about that when a transistor in an on condition means collector emitter voltage is low. Off condition means collector emitter voltage is high. So that VC1 is low means transistor Q1 in an on condition. VC2 is high means transistor Q2 in an off condition. So that the VC2 is high and this voltage is sufficient to forward bias the transistor Q1. That means the charge level in the capacitor C2 forward bias the transistor Q1. And the state, once the discharging is completed, for in state 2, VC1 is low and VC2 is high. Or VC2 is low, VC1 is high. So now state 2 is VC1 is high and VC2 is low. So Q1 is off condition and Q2 is on condition. This is continuously changes due to their time constant of R1 C1, R4 C2. The operation of this particular cross-coupled circuit for in state 1, VB1 charges up to through R3 below the ground towards VCC. When VB1 is reaches to their VB1 voltage level reaches to V on level means Q1 turn on and VCE saturation level to VCC to VCE saturation level. So that in that particular red color dotted line indicates the VC1 is initial condition is VCC. Once it start to conduct means transistor Q1 start to conduct means it reaches to saturation level, that is VCE saturation 0 level. Similarly for VB1 it reaches to V on, this is an V on position, negative level to positive level V on position. Once it reaches means start to conduct. Up to that particular time period VC2 is almost 0 saturation, it is an 0 level. Once the Q1 is on condition means Q2 switch to off condition, so that it reaches to 0 to shift from 0 to VCC level. Similarly for VB2 for a transistor Q1 Q2 positive to negative, and then the curve indicates that the capacitor charging and discharging. So in that particular mode the capacitance C1 cannot react as early as, so instantaneously cannot change the voltage, so that slightly changes the voltage, so that the transistor Q1 and Q2 the conduction it will take some delay. For the condition state 1, when transistor Q2 is turned off and VC2 charges, collector to voltage charges to R4 to C2, their time constant is R4 C2. Compared to R2 C1, this is speed compared to high speed, so that the capacitor charging and discharging turn on the transistor Q1. That means it forward bias the transistor Q1 compared to VB2 voltage. That is indicated in that particular part for blue color dotted line and red color dotted line. And then for in step 2, while transistor Q2 C1 is reaches their voltage level for V on means it forward bias the transistor Q2 so that VB2 reaches to on condition, V on condition. The red color dotted line indicates transistor Q2 base voltage VB2 is reaches to the positive level. So it shifts from off condition to on condition so that VC2 is pulled down from VCC to VCE saturation level, that is zero voltage. That indication is given by the blue color dotted lines. Okay. And then the VB2 is remained on condition means the voltage level of the VC2 get reduced so that transistor Q1 base emitter voltage or VB1 get reduced so that below the V on so that the transistor move from on condition to off condition. In that particular part, this capacitor C2 voltage is not suddenly varied so that the small duration of time delay, that particular time delay is shown here, that color dotted line shown here. Okay. So that the curvature shape is in the output side. Now the transistor Q1 in a turn off condition and VC1 is now shift from low to zero saturation level to VCC. That thing is indicated in the blue color dotted line. And then the VB1 is shift from positive to negative and capacitor charge towards the positive. That is also indicated here. The capacitor C2. And then the voltage level of the VC2 is shift from VCC to ground, VCC to saturation level. Okay. So this is the working process of this particular state 2. The final case, the both the transistor is on and off so that the output is either low to high or high to low. So VC1 is low to high and VC2 is high to low and then again reaches to high. So one full entire cycle period is completed. So this is then return back to the state 1 condition. Okay. So this process is repeatedly going on so that this particular oscillator does not require any trigger pulse, external trigger pulse to generating a choir wave. Okay. So that this is an unstable working principle of an unstable multivibrator is also known as a free running multivibrator. For an initial switch on condition, either transistor Q1 and Q2, any one of the transistor in the on condition, we cannot able to predict. Why? Because means R1 equal to R4, R2 equal to R3, C1 equal to C2, and Q1 and Q2 both are identical. So that the based on the parasitic internal capacitance, either Q1 and Q2, the charging up towards the VCC through R3, R2, and R3. So VB1 or VB2 get varied, rising voltages get varied. Based on that, asymmetrical operation is occurred any one of the transistor in a on condition. So that this is the operation of the multivibrator, unstable multivibrator. So in this session, we discussed about how the unstable multivibrator, cross coupled unstable multivibrator operation for different modes, and then we discussed about different input, how the behavior of the astable, monostable, and bistable multivibrators in the triggering pulses, and types of triggering pulses and their definitions: active high mode, active low mode, duty cycle, clock width and clock period, and clock frequencies. Okay, and what is the falling edge, what is the rising edge also. I think it is a better session for you. Thank you. Thank you, one and all.